This is multi-step equations, and you guys did a piece of cake, right? All you're going to do is you're going to use your inverse operations to isolate your variable. So when you do that, here we're going to add 6 on both sides. We end up with 2a is equal to 10. And then how do I get rid of the get the a by itself? Divide by 2 on both sides. So a is equal to 5. Is everybody clear? Okay. On the other side here, we want to get rid of our fraction. We want to get rid of that fraction first. Okay? So how do I get rid of this denominator? If this says n plus 1 divided by negative 2, how do I get rid of the negative 2? Let me read this again. This says n plus 1 divided by negative 2. You're going to multiply. Very good, because the inverse of division is multiplication, right? So we're going to multiply times negative 2 on both sides. Okay? When we do that, here the negative 2's will cancel, and we're left with n plus 1 is equal to negative 30. And then to get the n by itself, we will subtract 1 on both sides, and n is equal to what? 31. Very good. Negative 31. Is everybody clear with that warm-up? All right, so today's lesson is section 2.4. We probably will not be able to finish because of the pictures. But we're section 2.4 is solving equations with variables on both sides. Okay? And here we're going to solve linear equations and inequalities in one variable that include equations with coefficients represented by letters on both sides. All right? So that's what we're doing today. So the new vocabulary that we're going to talk about, the only new vocabulary is an identity. And we'll talk about that once we start solving equations. Okay? So, to solve an equation that has variables on each side, we're going to use the addition and subtraction property of equality to write an equivalent equation with variables on one side. Now, the addition property of equality, all that means is that if you add on one side of the equal sign, then you have to add on the other side. That's the addition property of equality. Same thing with the subtraction. If you subtract on one side, you have to subtract on the other side. And that's all there is to it. And that is how you keep your equations balanced using your inverse operations. Okay? So here we have an example. 2 plus 5x is equal to 5k is equal to 3k minus 6. Okay? You always want to start with writing your original equation. Okay? Then here we'll subtract we'll subtract 3k on both sides. Okay? On here, we don't have to start with subtracting 3k on both sides. Couldn't I also subtract 5k on both sides? Yes, it doesn't matter. Here, we're just subtracting 3k on both sides because we like to keep the coefficient in front of the variable positive. Okay? But that's just a personal preference. And then you continue with your inverse operations to isolate your variable. Okay? So, let's do one together. All right. So, for the first example, we have 3w plus 2 is equal to 7w. Okay? We want to first get our variables together. Okay? So, since we have the 3w on the left side and the 7w on the right side, we're going to move that 3w to the right side. Okay? What kind of 3w is that? Positive or negative? Positive. So how do I get it to the other side?
Subtract.
You subtract. Very good. So we're going to subtract 3w on both sides. And we end up, so this cancels here, we end up with 2 is equal to 4w. Then, to get the w by itself, we will divide by 4. Very good. So, w is equal to, and I do not want you to write this as a decimal. I want you to keep it as a fraction. So this is going to be 2/4, which simplifies to 1/2. Is everyone clear? All right. Very good. So here on example B, we have variable terms and constant terms both together. They mixed in. Okay. Now, what would you like to do first? Kendra? Okay, you want to add 7a? Now let me ask you this. Do I have to start with adding 7a? No, you don't have to. But it's just a personal preference just to keep it positive, right? So here, that 7a and that 7a cancel. Over here we end up with 12a plus 2 is equal to 6. Now, we still want to get the 12a by itself, the term that has a variable. So what do I need to get rid of? Tommy? The 2, so how am I going to do that?
Subtract 2.
Very good. So we're going to subtract 2 on both sides. We end up with 12a is equal to 4. And then to get the a by itself, we will divide by 12 on both sides. That 12 cancels, and a is equal to 1/3, 4/12, which simplifies to 1/3. And again, I would like for you to not to write it as a decimal. I would like for you to keep it as a fraction. Okay? All right. So grouping symbols. Now the grouping symbols, of course, are parentheses, right? And when we have parentheses multiplied, when we have an expression multiplied by just a number on the outside, using the grouping symbols, we need to use our distributive property, right? So here it says, if equations contain grouping symbols such as parentheses or brackets, we're going to use the distributive property first to remove the grouping symbols. Okay? So for example, here in example 2, we have 6 times the quantity of 5m minus 3. When you hear me say the quantity of, that means the next thing is going to be in parentheses. Okay? So here we have 6 times the quantity of 5m minus 3 is equal to 1/3 times the quantity of 24m plus 12. Now what they did here, to get this next line right here, is they used their distributive property right there. Is everybody with me? All right. So then you end up with this equation that the distributive property gave you. And now you just follow the steps as we did previously. Just use your inverse operations. Okay? So let's do one together. So for example 2a, the first thing we're going to do is we're going to use our distributive property to get rid of our grouping symbols. So when we do that, use our distributive property, we end up with 8s minus 10 is equal to 18 minus 6s, right? Now, I heard you say, let me pause this for a second. So now, we have an equation with variables on both sides, and we just need to isolate our variable using our inverse operations and our addition and subtraction properties of equality. So, what would you like to move first, the 8x or the 6x?
6x.
Okay, so we're going to, how do I move it? Very good. So we're going to add 6s here, and we're going to add 6s on the other side. Okay? So there, the 6s's cancel. This is going to give me 14s minus 10 is equal to 18. Now, we want to get the s term by itself, so what do I need to do? Very good. So you're going to add 10 on both sides. We end up with 14s is equal to 28, and now we can isolate our variable by doing what? Division. We're going to divide by 14 on both sides, so s is equal to, perfect. Anybody know how I check this? You what? Very good. Very good. You're just going to substitute your s back into your original equation, and if you get a true statement, then you got the right answer. If you did not, then you made a mistake somewhere.